So, as I said, the last time we have done uh, the CTOS one, Mr. Rahul Irregular has done a very good job, and the reason why I have kept him here is just to give him a round of applause that he has done a splendid job to explain about the CTOS application. Coming back to the about my introduction, myself, Nirav Darji, I am the project manager of GIS, working in Transerve Technologies for almost 2 years. Under me, I have a huge team, and we have worked on different sectors pan India. Majorly, we have worked on asset management, spatial urban planning, and slum rehabilitation. We are also working on fecal sludge management as well. Our developers are completely involved in this application pan India. On the top of that, we have given our application to many municipal councils where they have used our application for the survey, and they have received a good amount of written a kind of response from the public as well, and it has been a very fruitful experience for them. For all attendees, I want to just announce that please mute your audio and turn off your video so that other participants will have a smooth experience. It will not kill the bandwidth of yours as well, and all other participants as well. Our webinar today will be little short. It will be around 30-35 minutes or 40 minutes. Post this webinar, it will be a 5 minutes of break. And during this particular time, we are going to ask the questions, or we are going to welcome all the questions. We are going to answer those questions. And we are ready to answer during the webinar as well. One of my moderators is going to answer all your questions in meanwhile. So today, as I said, we are going to talk about the spatial analysis tool we have developed on Transerve Online Stack. Mainly, they are center of mass, mask, TAME, visibility coverage, and cluster k-means. For all this spatial analysis tool, we have taken some sample data from different part of the country, and those sample data I'm going to explain in the subsequent part of this tools. So let's start with our webinar today. Meanwhile, you can also download TOS Connect application from Android and iOS store. You can sign up on online.transerve.com for it is a free registration for now. You can try your hands on the application, and you can also suggest if there is anything you need to include, or you want something to you want the application to make to be in a better version. So for those who have not attended our previous webinars, I just want to give you a glance of this application, how the interface looks like. So on the left-hand side, where you have seen your data, where there is a complete total number of layers which I have imported in the application. There are total 900 layers, around 600 vector layers, and 27 raster layers. So it is this particular part will give you a statistics of the layer, how many layers you have incorporated in this application. On your right hand side, we have web map services and web feature services. So TOS will allow you to publish web map services which does not have any attribute value. It is just going to be only a base map. Web feature services will give you a very smooth experience to know about all the attribute values. So in our past webinars, we have already covered that. Please have a look on our YouTube channel, which will give you a very deep understanding of our application, and it will give you a kind of a tutorial as well. So map sessions, as many of those geospatial attendees can understand, that we have on desktop softwares, we have projects. So under TOS, we consider them as a map session. So under each map session, you can import as many vector or raster layers. There is another module where you can create forms for the survey. In our past webinars, we have also included this particular bit where how to conduct the survey, how to create the forms, and how to create projects, and the approval mechanism was also explained. Under data module, we have a vector layer, raster layer, and a field survey forms. Under vector layers, you can import your vector layers. It can be into KML, it can be into shapefile, it can be into DXF files. We are going to also update this application where we are going to include more features where we are planning to have a very smooth experience where you can download the directly integrate your shapefiles or KML or any geospatial information from your local drives, from your cloud as well. Raster files where you can import your geodef files and in ECW and also in ECW format. Field survey forms, as I said, you can apologies as my internet was a little disconnected. So let's start from again from the data module where you can import your vector layers, raster layers, and field survey forms. Under vector layers, you can import shape files, KMLs, and DXF files. Under raster layers, you can import your geodefs and ECW as well. Field survey forms where you can create forms which can be used in your survey activities. In our past webinars, we have also explained how you can create forms with conditions. And these conditions are quite useful where you have multiple ways to get the data. Projects, once you create any forms and you want to push the forms to your surveyor, you need to have a project, and under this project you have to assign map session, and you can also assign forms, and you can in brief you can write up the description as well. On Transerve Online Stack, we have two different roles. One is the surveyor and another one is analyst. As I said, analyst is the one who can use this application, use this web application. He is not allowed to use a mobile application, while on the other side, surveyor can only use mobile application. With his login, he cannot use web application. So right now, I am conducting this webinar as an admin, so I can assign as many analysts I want to, and as many as and surveys I can do. All the map sessions I can share with any analyst, and analyst can share their map session with anyone further. But surveyor do not have any access for this web session. So let's start with our today's agenda. Let's start with center of mass. So as I said, under vector layers, I have imported all my required vector layers, and all the shapefiles I've already imported and created a map session. And this map session can be considered as a project as well. So we have another functionality where you can also create a bookmark. So in a use case when you have to present any particular part of the maps, part of your map layout, then you can just create a bookmark, and on your login you can just go on that bookmark and it will pop up automatically there. It will drag you to that part where you have left. You can create PDFs. So let's start with our today's agenda. Today I'm going to talk about center of mass. So under tools, Under vector tools, we have so many different tools integrated. Under spatial analysis, we have a buffer, interpolate, intersect, isobands, mask, union, and Voronoi. Under geometry, we have centroid, envelope, merge, simplify, and tessellate. Under grid, you can create grids as per your requirement. You can create hexagonal grid, point grid, square grid, and triangle grid. Table join, where you can join your CSV with your shapefile. We are under kind of a rigorous testing for these raster tools as well. So we have a resource set where you can extract water bodies and you can find the bend differences. Under analysis, we have you can also compute a gradual path and a visibility coverage, which I'm going to talk about today, and a spatial filter as well. So our main concentration for today will be spatial analysis, where I am going to start with center of mass. So for center of mass, I am going to choose UP districts. I will select all the data. It will give me the points, as you can see on your screen. You can export this particular output as a permanent and temporarily, but on temporarily exported layer, you will not be able to style it. You have to export as a permanent if you want to further style or you want to do any kind of a further analysis. So I'm going to save it as a permanently, and we'll name it as a center of mass. We'll save it. It will take a little while. Meanwhile, I'm going to explain you how you can do further things. So the center of mass output you can export as KML in a shapefile, in a GeoGSR, in a CSV, and in a DXF format as well. You can see the attributes here. So let's go to layers. So as I said, it has already created the output. For further analysis, if you want to use a bubble map, you can also style them. We have already explained about this bubble map in our earlier webinars, so I'm going to give you a really brief about this. So you could see the bubble map is already been created. So in use case wise, this tool can be used for a representation of a polygon into point layers. As an example, it could be if you want to create a bubble map on a population data. So as you could see on your screen, I have created a bubble map on a population data. And with the size of bubble map, you can understand the density of the population of the state or a district. This is a district data. We can also join the table and use different types of styling. So if you have further data for each district, so say for example, if you have a water consumption or employment data for this particular districts, you can join the tables and you can represent that as a table, as a bubble map, and it will give you quite a good experience to understand the density and the severity of any such data. So the next part we are going to cover this is a building footprint of Tangent, which we have already created. The next tool which I'm going to explain is mask. This tool can be used to estimate the area. So say for example, if you have some built up area where opposite that built up area you have an open plot, and you want to find out the area of that open plot, you can create a mask and you can get the area of the unbuilt infrastructure, right? So I'm going to show you how this tool works. I'm going to select only one building. So say for example, this building have I want to just calculate the So as you could see, there are two different polygons it has created. In fact, four polygons, because there are some edges I have taken it. So the bigger one, which is 451, it is the area which is this one, right? The number 3. I can save it as a permanent layer. Again, with this, if you want to export it as a shapefile or as a CSV or a DXF, you can export as in that format. So, because of not proper digitization, you could see there are 4 different polygons it has created. The bigger ones is this one. It has a 451 square meter area. So this application can be used to estimate the area of plot where no infrastructure is built. So say for example, as I said, if we have a building footprint and we don't have any parcel boundaries. So by using this tool, we can subtract the area of built up area, and which will be the area of leftover or non-built up area. Our next tool is triangular irregular network, where I am going to use elevation points which I have created from the SRTM. So these points I have created in desktop software. The tool which I have run as a regular points. Using these regular points on some third-party application, I have taken the elevation of each points. So TIN is basically it represents the surface morphology. It is a method of interpolation where TOS supports the Delaunay triangulation method. Let me elevation points. As a property, I'm going to select as elevation. There is a limitation on this application. It could only show some very small chunk of data, but when you export it as a permanently or temporarily, it will show you the full output. So this team has created a surface where you can understand the terrain, and for further analysis, if you want to create a terrain, create a raster, you can use further interpolation methods, and you can export it into raster. So as you can see, it has created 10. You can export it as a shapefile or KML, and you can definitely use this shapefile in your other application as well. The next part is Voronoi, for which I'm going to show you an example of a recent case where, as you could see, this is the Delhi state, where we have a location of all COVID laboratories, and we have generated a Voronoi using the lab locations. So for which I'm going to show you how the Voronoi can be created. To save this time, I've already created Voronoi earlier. So I'm going to show you that. So as a use case, looking at the scenario where we are facing COVID pandemic, and if we have a COVID test centers, and we can create a Voronoi on top of it, where area of Voronoi polygon will show you the coverage of the area on the ground. This depicts the reachability of household to nearest COVID testing center. So, say for example, in a very general term, I would say this particular lab center are closer to this households. This particular lab will have access to, can be accessed by these households, while the furthest one, so out of Delhi, the nearest state have only one COVID lab where they can go that much far. The next part is our raster tool, where I am going to explain about the visibility coverage. This is a very interesting tool. In this part, you need raster image. You can use SRTM one band image, single band image. So under this, as I said, visibility coverage is you have to use elevation or thematic raster data sets to compute the visibility coverage of a selected point on a map. I'll also explain how it can, this tool can be used in a real cases. So let me start. I'm going to keep radius as a 600 meters. Enter observer height. So in this case, on some, say for example, some hilly terrain, if I want to install a communication tower, and height of that tower could be 10 meters. So that height I have to put on that 10 feet height, 10-meter height, if I want to put a sensor. So from that sensor, what would be the visibility coverage? That information will be given by this particular tool. We are also in the process to develop some other machine learning tools. So in future, in our next webinars, we are going to explain how deep learning and machine learning tools can be also helped in the GIS analysis. So this is one SRTM single band image. Enter visibility would be 600 meters. I'm going to keep that height as a, say for example, 5. And I'm going to pinpoint on some hilly terrain. So say for example, this is the hilly terrain I could see. And I will compute it. So the output would be in a green and a red color. The green color would be the reachability or a kind of a visibility coverage from this particular tower. This tool will take little time because this is completely working on an algorithm, and this algorithm will take little time. So as I said, there are many other tools we are going to integrate in this TOS. So for down the line, after 1 or 2 months, we are going to include so many different machine learning and artificial intelligence tools. So as you can see on the screen, the green part is the visible, can be visible from the tower, and the red part is are not visible because I have put the range, the radius as a 600 meter. If I expand it to 1 kilometer or 5 kilometer, that green can be seen in a different areas as well. So the next part, and this is the last bit of this webinar today, where I'm going to explain cluster K means, where I have district points of Pan-India. This cluster K means tool will, in this tool, you have to classify how many clusters do you want. On the basis of this cluster, so you can do the statistical analysis or any visual analysis you can do. So let me show you how cluster K means work. Say for example, I want only 5, and I want clusters to be created for all the district points. So there are around 720 districts in total in this data. It will take little time because it will create a backend algorithm. So now I have created a clusters. You could see on your screen, it has created the clusters. It has given some cluster numbers, cluster 1, 2, 4, 0. So for each particular district, it has given some cluster value. I'm going to save it as a permanent. It will take little time, but so it has created the output. As I said, for all the outputs from this vector tools, you can export as a shape file, as a CSV files as well. So my previous cluster district file, I'm going to switch it off. If I want to create a styling on the basis of the classes, I can create. The cluster is, these are the clusters, and I have to select the values. So like that, you can create a symbology, you can create styles for each cluster, so you can understand the how it is spreaded. I can also create on the basis of cluster. I can also do the statistical analysis. I can pick one parameter, and on the basis of that particular parameter, I can do further analysis. So yeah, this is how we have a tools on our TOS. You can also try your hands on this application. The application is completely free right now. If you need any kind of a help, please let us know. We will guide you, and we will make sure that you have a very smooth experience. So this is the end of the webinar. If you have any questions, please let us know. We would like to answer all your questions.